Okay, now we can start proper. Now that we have explained the conditions and the well-defined property, if a function is not well-defined, we say the function is ill-defined. Ill, like someone is not feeling well, like that, okay? So that will be the first thing we will be talking about today. Let's just write that as a definition. So let's go to the next part of our board. Okay. If f is not well defined, then it is ill-defined. Okay, an example is what we have just discussed. e.g., y squared equals x. This is not well defined. Okay, we have just talked about that. And this is because if this is not, right? So that is like you finding one counterexample. All you have to do is just find one counterexample. So if x is equal to maybe 25, okay, then y squared equals 25 implies that y equals plus or minus 5. And what this means is 25, 5, 25 minus 5 belongs to f. So this means it is not well defined. Okay? This means it is not well defined. And remember the definition of well defined. Whenever you have this first point to be the same, the second point must be the same. And in this case, the first points are the same, but the second are not the same. Okay? Can I ask you to check this, if it is well defined or not? It's an interesting function that I saw. Check this. Check if, say, is f of a over b equals a plus b well defined. Okay, check that. If you're ready, say something. Again, this is the well-defined definition. You need to have two elements, equate such that the two elements are the same, and which must produce the same image. Otherwise, it is not well-defined. You need to have two elements that can act, that f can act on. Has anyone tried? One is supposed to be not a function, right? We don't know. We don't know. We don't know if one is a function or not. But if it is well defined, then we can safely say it's a function because we can always manipulate the domain, right? We agreed on that. So you just check for the well defined. Is it well defined? So will a plus b be x? I don't know. You tell me. Look at the position of a plus b, look at the position of x, and tell me if your a plus b could be x. So tests for functions. Waiting, guys. Can you still see the entire board and nothing is covered? Yes, nothing is covered. All right, good. Anyone? All right, let's see. Mr. Cheng, you asked if a plus b can be x. Why would a plus b be x? Your x is always what you have in here. Am I right? Your x is always what f acts on, not what is produced. What is produced is your y. So your y is f of x. X is always the argument. So that's why your question was a bit surprising, looking at what you get. So it's like telling you f of x equals x squared plus 2, and you're asking if this is your x. Can your f act on this? No. Your f is acting on something to produce this. So this is your y. So this is your f of x. Does it make sense? So again, what you need to do is pick two elements that are the same. Pick two x that are the same. Okay? So I claim that this is not well defined. And I can tell you why it is not well defined. So I'm going to pick two elements, x1, maybe 1/3. I'll pick x2, that is the same as this, 5/15. Is x1 and x2 the same? Talk to me, guys. Yes. Okay, so let's see. So for it to be well defined, if x1 and x2 are the same, their images must also be the same. Do you agree? Yes? If these are the same, their images must also be the same. So we go to check the images. F of x1 means f of 1/3, which is 1 plus 3. But f of x2 means f of 5/15, which is 5 plus 15. They're the same. Since x1 equals x2 does not imply f of x1 equals f of x2. You see, this does not lead to this. Or I could say, since x1 equals x2, but f of x1 is not equal to f of x2, then what happens? Then f is ill-defined. Questions? Talk to me, please. So you just pick two elements and check. Okay, you pick two elements and you check. If whenever the two elements are the same, you can get different stuff. Okay, all right, let's move on. So some of these things at first stage might be confusing, but over time you'll be all right. Okay, so how can we check if something is a function or not? So there are three tests I want you to look at. We have two in our book. So we had one more. So the first one will be the arrow. You can check from the arrow diagram. You can check from the arrow diagram. What do we mean by the arrow diagram? It looks like this. Okay, looks like this. So if in your arrow diagram, everything here, so this, maybe this is x1, x2, x3, every x1, x2, x3 is mapped to something here. It could be y1. In fact, these two could be mapped to y1. And this is maybe y2. Yes, this is a function. Everything is mapped here. And there is no different, can you say, well-defined? Can you say, if my x's are the same, for x1, for example, is not linked to two different of this. So this is a function, okay? So this is a function because it is well-defined. But let's see the one that will not be well-defined. So if my arrow diagram looks like this, I call it G. So I have here x1, I have x2, and I have x3. May I draw that properly? Okay, this is even better. I never knew that was there. I have that. Okay. This is my G. Then I have x1, x2, x3, y1, y2, y3. Then I have this, and I have that. Can somebody tell me why G is not a function? Anyone, please? Why is G not a function? Yes, Callista, very good. Verna, very good. G does not map x2. Not all x are mapped. Not all x are mapped to y. Yes. So that's the reason. You're right. So let's see another one. So this is how you use your mapping diagram to check. For this function, I call it h. Or for this relation, it is a relation. It may not be a function. Okay? So for this relation, I have x1, x2, x3, y1, y2, y3. And this is mapped to that. Okay, that's actually what I was looking for. This is mapped to that. This is mapped to that. Okay. Look at that. Let's see. Okay. Is this relation a function? Why? X2 has two y values, two different y values. Yes. X cannot be paired with different y. Yes. I can hear from Leo and Brandy and Karen. Does that make sense? But can y have two x values? Can y have two x values? Yes. Okay, so let's write the reason beside it. So this is how your arrow diagram can help you. H is not a function, or should I say relation H, because it's a relation by default, right? It's a relation. Okay. Relation H is not a function. Because x2 is mapped to y1 and y2, where y1 is not equal to y2, right? And this actually means that we have x2, y1, and x2, y2 belonging to H, which is not supposed to be. Do you agree? That is the only problem. All X are mapped out. H acts on every argument in the domain, so we don't have a problem. Okay, we don't have a problem with that. The only problem is the X value is mapped to two different Y values. That's the only problem. In the case of G, so let's write the reason for G. So relation G is not a function because G does not take all arguments in the domain of G. X2 is left out. It means X2 has no image. And every point, every argument, by argument I mean the x values. Okay, argument means the x values. So arguments x values. So take note of that. So write this and say it is a function. So relation f is a function. Of course, we know the reason. Everything is mapped out and no x produce two images. So it's as simple as that, but we won't write that. So relation f is a function in the first one. Okay. Relation f is a function. Is that okay, everyone? So the arrow diagram can help you decide if it is a function or not. Okay. What else can help us to decide? The algebraic method. The algebraic method is to consider these conditions. If f is mapped, so you check by, try and error or otherwise. You check, oh, can everything be mapped? Yes. Oh, is this well defined? Yes. Then you can say, oh, indeed it's a function. So algebraic method is the second, and the last is the so again, I wrote here test 1. So test number 2. Someone saying something? Can you go very quick? I didn't catch the last one. Okay. Can you see me on your screen? Because I keep moving myself around. I hope yours is not moving. Is it moving? So as I'm moving this around, okay, it's not moving. So the control is only on my side. All right, good. How about now? Can you still see me? Oh, okay. So it's only for my, all right, okay. Just wanted to be sure. All right, good. And there is no gray spot or whatever like the last time. We're good. Everything is full screen. All right, good. Perfect. I think we learned from yesterday. Thank you. So the algebraic method is the second. Remember the first one, you can use arrow. Algebraic method here, you test this condition given here. These conditions. This is the algebraic method. So I'm just going to write it properly. It takes the conditions 1 for A, F, it takes the conditions, F maps every argument, and B, F is well defined. Okay. And so usually you just check the well defined. You don't even have to go through that. Okay, let's see. This is, like I said, this is the major thing you need to check. The first one, you can forget about it. So the last, we're not going to waste time on that. The last condition is graphical method. or should I say geometric. So by drawing the graph, so what I have to do here, draw or sketch the graph of f, then move a straight line, a vertical line. Along x-axis to see if there are two y values at any point for same, to see that there are no two y values for the same x value. I'll show you that. So these are the three ways you can check if something is a function or not. Can you still see the board? Okay, good. Because I'm about to show you something. Let's see. That would be on page 396. 396. All right, it's an example. So I'm going to share my screen now. Can you see this? My book? Okay, so let's look at this software demo. So we're going to run the vertical line test. The vertical line test is the last condition you have just written. We want to see, this is the graph of this relation, okay? This is the graph of the relation. Now we want to see if this relation is a function. Can everybody see my screen? Yeah, okay. So this is the graph of this relation. This is the graph of this. This is the graph of this, and this is the graph of this. So let's begin with this. So once I click run test, we're going to see a straight line moving here. And if at the end of the movement, it does not encounter for a particular x two different y's, then it's going to conclude and say it's a function. So are you ready? Let's go. Keep your eye on the screen, please. Can you see throughout, there was no point where, let's run it again. You see, it's moving, it's moving. There is no a single position where you have for one x two different y's. Okay, so and the conclusion is here. So you also look out for the bottom of the screen. Okay, you look out for the bottom of the screen. Am I making sense? So this is the geometric method. Okay, that's what we have just done. Okay, let's say the second. This is another, graph. Let's run the line test. Can you see that? Okay. Do you think the line test will succeed in this? No. Because the moment it gets here, okay, it's going to fail. Let's see. Bum, 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 bum. Fail. Let's run it again. Can you see? Two different y's. So this is 1, negative 6, 1. This is negative 6, no, negative 6 minus 1, negative 6, 1. That's a problem. Understood? Good. Let's see the last one. Remember, this is the equation of a circle. We discussed the equation of a circle. Oh, at the bottom of this, there will be a conclusion here. It's not a function. Can you see? The relation is not a function. So let's see. Do you think the circle will pass the line test? No, for same reason, right? So let's see. Bam, bam, bam. Fail, fail, fail. So for example, in fact, from here, actually, it fails from here. So this is just a point that, it doesn't mean this is the only way it fails. And it failed as it continues to fail. So look at this, minus 4.5, 3.97. It's same minus 4.5, but negative 3.97. So this is the line test. If you have the sketch, just move horizontally, a vertical line, not horizontal line, a vertical line, and see if you can meet two different y for the same x. If that fails, the relation is not a function. If as you move throughout, it does not fail, then the relation is a function. Any questions? Anybody? Okay. All right. So I'm going to give you some, look at this. Now look at this. Oh, okay, I think this was about some functions that are not continuous, that have jump something. Okay, let's see. Okay, don't worry. Okay, this is just an explanation. Of course, we know this. If you have open circle, it means the point is not included. Do you guys remember this? This is a case of less than and less than or equal to. Do you guys remember that? Hello, talk to me, please. Number line. Does everybody know number line? I need everybody to respond. No, okay. Karen is confused. Confused.com. Let's come here. Only Karen said no. Does it mean only Karen does not understand? If you want to draw x less than 2, the number line will look like this. At 2, you have that. But if you want to do x greater than or equal to minus 3, yeah, you remember now. So at your minus 3, of course, you have minus 2 right here. You not only do this, you shade. Okay, so that's what they're saying. Aha, everybody remember now. Aha, okay. So that's what this means. So if you see this, this is what it means. So can I ask you to attempt, look at question 1. Which of the following set of ordered pairs are function? Is this a function and why? Is this a function and why? Use algebraic method to decide whether these relations are function and explain. And here, use vertical tests to determine which of these relations are functions. Let's begin. It's not difficult. Okay, maybe I select for you. I need you to do 15A. I'll write it in the, sorry, excuse me. I need you to do 15A, exercise 15. Exercise 15A, question 1A, question, maybe 2A also. Then I need you to do 3CD. All right. It's on your screen. So everybody knows how to send a private message on this group chat, correct? Yeah, private message here, okay? So send me a private message here. Send me a private message here. You don't need to send on WeChat, okay? It's not going to be a recorded graded activity. So let's just practice from the book. Okay, got your message? Okay. Lillian got the first one, 1A correct. Vena. Yeah, Vena correct. Krista K, yes, which is Krista Q, yes. Yeah, correct also, Mr. Cheng. So Mr. Cheng, check that, please. You can't say every value of X is marked because you don't have the complete domain. You can only say that if I give you the domain and you realize I left something out. This is all you see. Maybe this is everything. So think again. Send me another reason. Exactly, that's your reason. That's correct now. Nakita, instead of related to, mapped to Y is better, okay? Oh, you sent to everyone. Don't worry, we're gonna deny you coffee. Well-defined. All right, try to break it down next time, what you mean by well-defined. So yes is a well-defined function. Okay. Callista, you said all X are marked. No, that's not concrete enough. You don't know if this is every X. What if my domain is set of natural numbers between 1 and 100? And this is all you have. Then not all X are marked. Okay? But usually, if we have this, we're actually telling you this is everything about the domain. I'm only saying you shouldn't use that argument. All right? The argument shouldn't be about all X are marked. So think of another argument. Think along the well-defined argument. Yes, Brandy. Instead of the word links, Brandy, use the word marked. Is that okay? Use the word marked. So when you're writing it in your notes, please write marked. Marked. Use algebraic method. Okay. So Cheng got your 2A. Yeah, you're right. Clarissa is a function because yes, Clarissa, you're right. Callista, yes, you're right. Krista K is a function because okay, yeah, you gave me more than enough explanation. That's okay. Krista K. Are you sure, Nakita, you want to check that 2A again? Sure, there are two values for y, for one x. Are you sure? Leo? Perfect. Leo, that is correct. Instead of saying every value, okay, Leo, you can say for every value of x. That's also allowed. And this is also perfect. So whichever that is convenient for you. 3C. Yes. 3C is correct for Mr. Cheng. Krista, you said, oh, Krista is showing me something here. Oh, Krista, what are you saying? Because when I scroll down your message, I don't go back. So what is your point in number 2? Krista, what's your point? You only had an explanation. Are you saying it is not a function or it is a function? What's your point? Yes. Clarissa, you're right. For 2A. Lillian, you're right for 2A. Ethan Chang, you're right for 3D. Very good. Yes, you're right. Krista C. Krista C, I need to, yeah, I was talking about Krista, not you. Krista C, can you check what you sent to me last? What exactly do you mean? Are you explaining why it is a function or why it is not a function? Clarissa 3C, accepted. Nakita, yes. For all values, yes. At most once, yes, only one place, yeah. Krista, I got that now. But Krista, can you look at what you sent above about number 2? You have not responded to that. Is a function. Okay, got it now. So always include what you intend to say before your explanation. Yes, and I saw your number 3C, Krista C. Very good. 2A for Callista. Are you asking a question? Callista, are you asking a question in your 2A? I can see question mark. Are you asking me if it is well defined or are you telling me it is well defined? Please clarify. Copy what you are saying and paste it again in a clear form. Then I'm looking at your 3C now. Yes, Vena, you're right. Lillian 3C, also correct. Krista K, you're right for 3C. Yes, Callista, you're right for 2A. D, Lillian, you're right. Two A, Brandy, you're right. Leo. Leo, because any value of x, there is only one corresponding value of y. You will say for any value of x, not any value of x. The word for should be included for any value of x. And you don't have to put the last one, the maximum value of y corresponding to the value of y only have one value. That's that is just complicated and confusing. The first sentence is okay. That's all I need. Callista, I'm looking at your 3C now. Callista, you keep typing something without conclusion. Okay, I've seen it. Okay, got it. Please write, simple sentence and go straight to the point. Then I've seen your 3D, that's correct. Clarissa, I've seen your 3D, that's correct. Brandy, I've seen your 3C, that's correct. Callista, I've seen your 3D, that's correct. Krista C, 3D scene, that's correct. Nakita, can you explain your 3C? I don't think your argument is true. Please check 3C. Okay, check what you sent for 3C. Karen 2A, you're right. It is well defined indeed. Brandy, you said D. Well, I assume you mean 3D. Please, what if I've given you some 4D or from 2D? So make sure you always write in full. So yes, you are right. 1A. Why is Krista just talking about 1A after you have done like 3D? Okay, the correction. Okay. Well done, everybody. Well done, everybody. This is wonderful. So this is a function because it's well defined. Okay, we do not have a case of same x with two different y. We don't have it. Okay, in fact, we have different x. Okay, we don't mind if we have the same y. All right, so this is well defined. This is also well defined because you can have, you don't have a case where we have the same x producing two different y's. That's not possible. Same x, we're not talking about same y. Okay, we're talking about same x producing two different y's. Nakita, I saw your work now. It is a function, yes. Karen, I saw your work is a function, yes. So well done, both of you. So for which other one, 3C, if you use the vertical line test across, you will only meet one y. So this is yes, it's a function. Has everybody done 3D? Karen, have you done 3D? Doing. Nakita says doing. Leo, got your work? Leo, yes, you are right. But you didn't write the reason. Okay, make sure you put the reason when you're writing in your notes. Karen, okay, has everybody contributed to this discussion? So I give Karen and Nakita a few more seconds to type in their comments. Well done, everybody. This is good. Now, I think the idea of function is clearer to us, and the idea of well-defined is clearer to us now. Okay, is it safe to say that? That's better than yesterday. We now can identify, aha, good, that's the whole thing. Sorry, there's a construction going on. I hope it's not too loud. Karen, I got your work. It's ill-defined. I like that language. Can you explain why it is ill-defined, Karen? Explain why it is ill-defined. For same x, there is more than one y at some points. You need to include at some point because it's not in every point, right, Karen? It's not in every point, at some point, yes. So you need to include it. If that graph was labeled, you will point out that particular point. But the graph is not labeled, so we don't know the value of x. So you just say at some point. Well done. Nakita, have you been able to send your last work? Okay, I just saw it. Yes, so it is ill-defined. Well done, well done. This is acceptable. Well done. So we are all good with this. The next thing is for us to be able to write our domain. Or should I go to notation first? Oh God, how loud is this construction? Talk to me, guys. How loud is the construction here? It's loud? Oh my God. Sorry, you have to endure. I don't know. They're fixing something upstairs. I hate it when stuff are very loud. Okay. Okay, I think what we'll do. Oh no. You guys are not doing this to me. This is so annoying. Please just reduce the volume. Just reduce the volume of whatever you have. So let's try to wrap up stuff. It's actually 3:39, so we're probably gonna leave. So let me see something short we can do. Maybe we do function notation because that's something short and something easily that I don't need to spend a lot of time to explain. My initial intention is to explain the idea of domain and range of function, but we'll need more time. Okay. Oh gosh. Apologies, please. Let's talk about function notation. All right. So everybody, function notation. Please, can you still manage to hear me regardless of this crazy noise? Okay, thank you for that. I heard according to the Macau law, they can do their construction within maybe 7 a.m. and 7 p.m. or something like that. So this idea of function is like your input output that you've learned before, okay? So I'm not gonna waste time on that. So if you have, let's say you have a washing machine. So you put in your dirty clothes in the washing machine, okay? And the washing machine does some magic and the clean version comes out. So this is your input and this is your output. And this is where all the operations happen. All right. So we can say when F acts on dirty clothes, it produces the clean, the clean version of your clothes. So function is like that. Okay. So function is that process that maps them from one to another. So the basic notation that we function, let's see. Okay, so let's just write. If f is a function with domain of f equals to a and range of f equals to b, then we write Write that. So if for x in A, f maps x to some y in B, this we already know. Then we write f of x equals to y. Okay. Y is called the function value or image of x, okay, under the function, or the image of x. On the other hand, x is called the arguments of the function, or function arguments. Or the, can somebody guess? Or the what? Anybody? Pre-image, yes. Or the pre-image. Pre-image of what? The image of y, thank you. The image of y. So, these are just notations and definitions. Can I move to the next slide? All right. So we can just get out of here soon, okay? So I will be asking you to evaluate a function. So let's see. There are some, I'm taking my question from exercise 15B of your book, if you have it. Sometimes, rather than say, maybe another notation now, if notes, if f is defined as, say, f of x equals ax plus b, okay? We can sometimes write as f, and you have two columns, x, and you have that. Actually, the vertical line is better. So you might be seeing this. Okay, yeah. So it's possible you have something like that. Okay, I put that right. Yeah. So this notation is actually the same as saying f of x equals ax plus b. So by the time I write some problems, and either of the notation you see, please don't be confused, is the same thing. Is that clear? All right. So I'm going to leave these problems for you to try quickly. So try this. Attempt. So I'm going to write the stuff so you can, I'm going to mute myself because I'm not talking anymore because of the noise. So you just attempt the questions. Anyone? Int for 2b. What is another way of saying does not exist? Undefined fraction. Is that okay, Mr. Cheng? Yeah, that's all you need, bro. Just remember one interesting question from a Nigerian curriculum. Right. Does anybody need clue for any of the questions? Because otherwise, I'll leave you with this. Is there anyone you want us to attempt before we go? Say something, please. Or you just need to take your time to work it out first and maybe bring whatever problems you have next time. Just need time, okay? So how about we, spend time to go over it on our own? 3A, somebody said 3A. Brandy said 3A. Yes, just need time. All right, Brandy said 3A. Can somebody give us a clue to 3A? Use your mic, please, preferably, so that Brandy could hear you properly. Anyone? 3A? Just give us clue for 3A so that Brandy could take his time. Who is speaking, please?
Me.
Me. It's me.
Lillian.
Hi, Lillian.
That rhymes. Just substitute.
Substitute what?
Just the x plus 4. Substitute x plus 4.
Yeah, that's it, Brandy, yeah. X for x plus 4, yes, you are right, Brandy. That's what she's saying. That's it. Because remember, the meaning of this definition is that this is your argument. Whenever this f acts on an argument, anything it acts on, anything xf acts on, it will be 2 times the square of the same argument plus 3 times the same argument minus 1. We don't care what this argument is. So if this argument is as huge as dinosaur, it will be 2 times dinosaur squared plus 3 times dinosaur minus 1. Nobody cares what the argument is. That's the definition of the function. If this was you, Brandy, and you are an argument, it will be 2 times Brandy squared plus 3 times Brandy minus 1. So all these guys, we just serve as the arguments. What happens to any arguments? You follow the function. That's what Lillian is trying to explain to us. What she has explained to us. Is that clear, Mr. B? All right, good. Any other question from anyone? Can I get a yes or no? Nope. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That. So please pay attention to this question 4 especially. Make your attempt. There'll be no clue for question 4 today. If you run into trouble, we'll discuss it on Thursday. All right? So apart from that, there'll be no homework. This is all you have to do at your leisure. I'm going to write that properly. My OCD won't let go of 3/2 because it's not properly written. Okay, now the OCD in me is satisfied. All right, so play around with this. Yeah, like yeah, OCD. You're also satisfied. Nakita is not OCD, she's OCD++. Karen is OCD. Lillian, OCD. Yeah, mathematically, she's OCD. But in terms of writing in their notes, Nakita is number 1. Is Karen number 2? I think so. Is any of the boys OCD? I don't think so. Brandy is? He said no. Really? Brandy, everyone is saying you're OCD. Yes, you know, he used the white out all the time. You know, any slight mistake, so much correction fluid in his note. Yeah, all the time. So Brandy, I think that qualifies you for being OCD. He copied all his notes into a new notebook. Are you serious? Oh my God, bro, I give up on you already. Okay, guys, I'll see you on Thursday. I smell something nice and I don't want my wife to finish everything, so I'm gonna get out. Can you guys see what she's doing to me? Like, seriously? You know, I mean, who make toast bread and flash it in front of a teacher? Isn't that mean? Yeah, I know, right? Okay, I'll see you guys on Thursday. Have a great time and rest well tomorrow. And we'll talk more on Thursday. Okay, bye. Still on functions. Bye.